Hello and good day. My name is Muhammad FITRI bin ISHAK. So our group has been given task to propose pedestrian bridge at Batapahat River. So as you can see, this is my group member. For the detailed project, for the introduction, the town council was proposed to build a pedestrian bridge beside Tun Razak Bridge. The focus of this project is to propose a pedestrian bridge, to propose a structural system for the pedestrian bridge, to design the pre-stress element of the pedestrian bridge. So what is pedestrian bridge? Pedestrian bridge, also known as footbridge, to provide a safe mode of passage for cyclists and walkers and often enrich the area. Function is mode transfer forking pedestrian to cross pedestrian around area with very high vehicle movement. Are typically built to allow people to cross a space, water, or a physical geographic feature. So there are 7 considerations for long-term success. First is determine width, site condition, geotechnical analysis, abutment plan, permitting, safety, and durability.
Hi, my name is Muhammad ZIQRIEL bin ZAINUDIN. Okay, I would like to present about the structural system. Okay, for a pedestrian bridge, it has the similar structural system with the normal bridge. A bridge is divided with two parts, which is upper part and the lower part. Okay, for our pedestrian bridge, the structural system we use the composite component, which is the steel deck, pre-stressed concrete beam and slab. The steel deck were used and supported by the slab and the beam. For this bridge, we design as simply supported. Okay, the simply supported bridge have multiple characteristics that may be seen as advantageous. Thank you. Okay, as you can see in the slide, this is the basic design outline of the simply supported bridge. Okay, if the bridge has the longer span, we must add the support at the middle of the span.
Good evening to my lecturer, Dr. Ko, and my fellow friends. My name is YONG, and today I'm going to present the software analysis part of my project. So first, the software that we selected to be used is ZIQRIEL. There are few steps of software analysis. First is modeling, followed by properties assigned. Next is to generate a 3D views, and last is to run analysis. For modeling, first, we create a model first. As we can see that there are few elements in the model, which is column, beam, and also the plate. Next, we proceed to assign the properties. For the column, we assign the sizes and also the material. Next, for the beam properties, same as the previous, we assign the properties, which is sizes and also the material. Next, we proceed to the plate properties. As usual, we assign the thickness and also the material to be used. So after every properties are assigned, we can generate the 3D views. And the 3D views should be like this. So lastly, we can run our analysis. That's it from my part. Thank you.
For the manual calculation, we have calculated two components. First is slab, second is I-beam. And the slab, we have used normal RC method to calculate it and propose a thickness of 250 mm, which includes the metal deck of 0.133 kN per meter square. And the main reinforcement calculated is as shown here. While for the I-beam, we have used type I7 beam, which is extracted from the Hume concrete standards, and proposed the pre-stressing force of 3,600 kN, eccentricity of 400 mm using Krishnamurti-Magno diagram to calculate, and propose a superstrand 7-wire strand with diameter of 15.2 mm. And here also shows the area, tensile strength, and breaking load of the tendons. And the method we use is pre-tension method.
So for the I-beam, for the moment is 231.36 kilonewton and the shear is 985 kilonewton. And for the short term and long term loss due to shrinkage loss, 7.45% and 38.24%. And for ultimate moment capacity, 2740.47 kilonewton and the shear is 248.2 kilonewton.
Now, I like to continue about component and materials. For the first component is girder. A girder bridge is a bridge that uses girder as the mean of supporting its deck. For the second component is steel deck plate, usually a welded integral part of the bridge deck, and it can be quite thin. For the next component is decking, made of concrete poured over a metal framework that serves to strengthen the entire assembly. For the last component is slab. A slab can be cast as two beam sections with a thin layer of slab spanning between them, or as a uniform depth slab spanning between 2 points. For the materials, we use concrete and steel. For the concrete, commonly used for many bridge superstructure members such as deck, prestress concrete, beam, curb, sidewalks, and parapets. For the steel, commonly used in the bridge superstructure for armoring, expansion, joint beam bearing, floor to beam, girder, reinforcing bar in concrete, traffic barrier, and trusses. So that's for me. Thank you.
Okay, for the conclusion, the pedestrian bridge were designed successfully. The calculation method were following based on the prestressed concrete design, and other than that, the implementation of prestressed concrete design seemed very effective and economical to the construction. Okay, that's all for us. Thank you.